Welcome to the Survival Bunker. Here we study the brutal reality of surviving war zones, sieges, and battlefield collapse. Imagine, if you will, sitting in total silence while the world above you is literally being torn apart by high-explosive bombs. For Londoners back in 1940, these deep-level shelters were the only thing standing between life and extinction. Tonight, we descend 30 meters into the damp silence of abandoned tunnels, trace the cast-iron skeletons that absorbed the shock of the Luftwaffe's worst nights, and examine the structural ingenuity that turned London's clay geology into the greatest civilian survival system in recorded wartime history. Before a single shelter was dug, London possessed a hidden geological asset that no other major European capital could match: London blue clay. This dense, waterproof stratum sits beneath the city at depths ranging from 15 to 40 meters, and its properties are honestly quite extraordinary. It does not crack under pressure. It absorbs vibration instead of transmitting it. It contains and dampens explosive shockwaves. Engineers who understood this material understood something the Luftwaffe never could: that the ground beneath London was already a weapon of survival. When the London Underground was first proposed as emergency civilian shelter in September 1939, the government rejected the idea outright. Their concern was structural. Tube station platforms sat at shallow depths, many constructed using the cut-and-cover method, meaning the ceiling above commuters was little more than brick and compacted fill. A direct hit from a 500-kilogram SC bomb, the standard Luftwaffe high-explosive ordnance, would have turned a platform shelter into a mass grave. Everything changed on the 7th of September 1940. The Blitz began in earnest that evening when 364 German bombers struck London for 57 consecutive nights. Londoners did not wait for government permission. They flooded the tube stations by force, occupying platforms, ticket halls, and connecting passages. By November 1940, an estimated 177,000 civilians were sleeping underground each night. The government, recognizing the inevitability, commissioned civil engineers to assess whether the existing network could be reinforced and whether dedicated, deep-level shelters could be constructed beneath it. The answer was yes, and the project that followed became one of the most extraordinary feats of wartime engineering ever attempted. Construction began in 1940 on 8 deep-level shelters, each bored 30 meters below the surface, directly beneath 8 existing Northern and Central Line stations: Belsize Park, Camden Town, Goodge Street, Chancery Lane, Stockwell, Clapham North, Clapham Common, and Clapham South. The depth was deliberate. At 30 meters, the structures sat entirely within the London blue clay stratum, shielded by the one material the Luftwaffe could not destroy: the skeleton of resilience. Descending into one of these shelters today, the first thing that strikes you is the geometry. Every tunnel is circular. That shape was not an aesthetic choice. It was the only rational response to the physics of an aerial bombing campaign. When a high-explosive bomb detonates at or near the surface, it generates a shockwave that travels outward in all directions, including downward. A square or rectangular tunnel creates stress concentration points at every corner. Under sufficient blast loading, those corners become failure zones. A cylindrical tunnel has no corners. It distributes compressive force evenly around its entire circumference, converting a potentially lethal point load into a diffused hoop stress that the cast-iron lining is specifically designed to handle. Each tunnel was constructed from modular cast-iron segment rings, bolted together in sequence as the greathead shield bored forward through the clay. A standard ring consisted of 8 curved segments, plus a key segment at the top, each segment approximately 600 millimeters wide and 25 millimeters thick. The bolted joints between segments were packed with lead caulking to resist water ingress, and each ring was grouted to the surrounding clay through injection holes that pumped cement grout into any voids in the annulus. That grout was the critical detail. It fused tunnel to geology, converting a steel tube floating in clay into a unified structural system. The entire assembly became a single resilient organism rather than a collection of discrete rings. Goodge Street shelter provides the clearest surviving example of this engineering logic. Taken over by General Dwight D. Eisenhower in 1944 as his forward command post during the planning of Operation Overlord, the shelter survived not only the Blitz, but repeated V-1 flying bomb impacts on the surrounding streets in 1944. The cast iron rings were examined post-war and found to have sustained no structural deformation. The geometry had done exactly what the engineers intended. Structural integrity alone could not keep civilians alive. A sealed cylindrical tunnel 30 meters below a burning city presented a second, equally lethal threat. The atmosphere inside would kill every occupant within hours if it was not actively managed. Each deep-level shelter was designed to accommodate between 8,000 and 10,000 people during peak use. Now 10,000 human beings in an enclosed space consume oxygen and exhale carbon dioxide at a rate that would render the air dangerously toxic within just 2 to 3 hours without mechanical intervention. The engineers solved this with a ventilation system that ranks among the most cleverly concealed elements of the entire project. At the surface, each shelter was connected to a series of ventilation shafts, disguised as ordinary brick buildings. From the street, they appeared to be utility substations, storage annexes, or unremarkable wartime structures, really the kind of building a Luftwaffe intelligence officer would photograph and discard. Inside, they housed large centrifugal fans capable of moving thousands of cubic meters of air per hour. The intake shafts drew fresh air from above, while exhaust shafts expelled contaminated air through separate outlets. The designers anticipated the scenario in which surface power supplies were destroyed by bombing, which, honestly, happened repeatedly throughout the Blitz. The electrical systems for the fans were connected to independent generator sets housed within the shelter itself, insulated from surface infrastructure. In the event of a total grid failure, the generators could sustain ventilation for the duration of an attack. Hand-operated emergency bellows were also installed at multiple points as a final failsafe. The system was designed to function even if every power source above ground was simultaneously destroyed. A shelter that could only keep people alive in darkness with no food, no sanitation, and no medical care was not a shelter. It was a holding pen. The engineers and planners who designed the deep-level shelters understood this, and the layouts they created reflected a sophisticated understanding of what it means to sustain human life over extended periods of intense stress. Each shelter consisted of 2 parallel tunnels, each approximately 400 meters long and just over 9 meters in internal diameter, connected by cross passages at regular intervals. The upper tunnel in each pair contained a continuous row of 2-tier bunk beds along both walls, with a central walkway just wide enough for 2 people to pass. Every bunk was numbered and allocated to a specific registered civilian. This was not informal. A ticketing system operated at the shelter entrances, assigning families and individuals to fixed berths to prevent overcrowding and to allow shelter wardens to account for every occupant in the event of a casualty. The lower tunnel housed the support infrastructure. Canteen facilities with electric cooking equipment served hot food twice daily. First aid stations, staffed by trained medical personnel, occupied dedicated cross-passage sections. Chemical latrines, partitioned and ventilated, were positioned at the ends of each tunnel run and cleaned on a regulated schedule. A telephone exchange connected each shelter directly to the London Civil Defence Control Room, enabling real-time communication about attack patterns, structural conditions and casualty management. Clapham South shelter, which operated as a civilian refuge from 1940 and was later used to house 492 of the first Caribbean immigrants who arrived on the Empire Windrush in June 1948, preserves the most complete surviving example of this internal layout. Surveys conducted in recent decades confirm that the original bunk configurations, canteen fittings, and first aid station partitions remain largely intact 30 metres below Clapham High Street. The 8 deep-level shelters were never completed in time for the worst of the Blitz. Construction concluded in 1942, 2 years after the bombing campaign had peaked. But the structural principles they embodied survived the war intact, and their influence on both military and civilian protective architecture extended far beyond 1945. Lidar scanning surveys conducted between 2022 and 2025 have produced the most detailed topographic maps of these structures ever assembled. The scans reveal something remarkable. The cast-iron ring systems installed during wartime construction have experienced negligible deformation over 80 years of continuous loading from the city above. Modern London skyscrapers, including developments in the Nine Elms and Vauxhall corridors, have their foundation piles driven into ground that the deep-level shelter grid helped stabilize. The wartime engineers, working without computational modeling or finite element analysis, produce structures that continue to perform within acceptable engineering tolerances in 2026. Several of the shelters have been converted to entirely new purposes. Clapham North now houses a hydroponic farm operating under the brand name Growing Underground, producing salad leaves and micro-herbs for London restaurants. The controlled environment 30 metres below street level, constant temperature, zero wind, total protection from atmospheric contamination, is, ironically, the same environmental stability that made it an ideal civilian refuge in 1940. Goodge Street shelter, declassified only partially, has been used as a secure telecommunications facility. The principles of physical isolation, vibration dampening, and structural resilience that protected Eisenhower's planners in 1944 now protect server infrastructure. The deeper lesson of the deep-level shelters is not architectural, it is doctrinal. The Blitz killed 43,000 British civilians. It left 1.4 million people homeless. It destroyed or damaged over 1 million buildings across London. But it did not break civilian morale, and it did not break the city's ability to function, in significant part because a group of engineers, administrators, and civil defence planners made the decision to invest in serious protective infrastructure before the worst of the crisis arrived. The survival rate among registered shelter users throughout the Blitz was exceptional. The structures held, the systems held, the people inside them held. In the context of 21st century conflict, the principles developed in London between 1940 and 1942 are not historical curiosities. They are active references. Every contemporary civil defence manual that discusses deep shelter construction, blast isolation, or subterranean air management traces its intellectual lineage, directly or indirectly, back to the decisions made in those wartime engineering offices. The clay shield beneath London taught the world what civilian protection actually requires: depth, geometry, ventilation, and the discipline to build the system before you need it. The deep-level shelters of the London Blitz are proof that survival at scale is an engineering problem as much as it is a human one. The people who built them did not panic. They calculated, they designed, they built systems that worked. If this kind of detailed, evidence-based survival history is what you come to this channel for, subscribe to the Survival Bunker right now and hit the notification bell. Every week we go deeper into the sieges, the collapses, the campaigns, and the underground worlds that kept human beings alive when everything above ground was trying to kill them. Share this video with anyone who wants to understand not just what happened in history, but why some people survived it and others did not. That knowledge is never useless.